All right, hey everyone. Welcome back to part two of the Pokemon Save Editor. Since the last video, I've kind of fleshed out a few more ideas. I haven't actually read through this yet before, because I wrote this last night, so I haven't actually read through this yet before jumping in today. So we have kind of like a main goal, number one, which was like, can we hack ourselves in a level 100 Mewtwo as if you know, it's 2005. We've got an action replay. The world is our oyster. Can we give ourselves a hacked Mewtwo? So I'm kind of thinking some basic concepts that we kind of want to work through first, because this is definitely something that we have to build up to, because there's actually quite a bit to the save data structure in Gen 3. There's some things that we need to consider, such as making sure that we don't overwrite the signature, that we're calculating the checksum correctly, that we're actually modifying the correct save, and so on. So there's definitely things that we need to do first. It's not necessarily going to be something that's that straightforward or easy. So yeah, I kind of itemized these, and some of them we've pretty much already done, creating relevant structures and loading the save data into them, enumerating each section and anything else that requires it, reading the checksum of a section, calculating the checksum, determining the save block to be edited, which we kind of did in the previous session. And then I want to start with something really basic. So if we can calculate the checksum, then let's make a very basic change, such as changing the trainer name. And if we know that we can modify the data, then we're ready for kind of the next step, which is to dive into the Pokemon data structure and to actually figure out how we can give ourselves like an AirSats fake Pokemon. So let's start with, so when we actually do move on to Pokemon, we'll probably do something very basic, like a Pokemon with one move, and then we'll go for a fully kitted out level 100 Mewtwo. So we're definitely building up towards something, slow going at the beginning, and then there's just kind of some basic ideas here for what we can do afterwards. We're working with little endian data, which I think is going to make calculations potentially kind of tricky. Are there other things that we can edit in our program? Can we actually make it something that does more than hacking in a level 100 Mewtwo? Can we actually pick what we want to do? And if we do that kind of thing, then we probably need some kind of command line interface or a TUI. I mean, some things are definitely easier than others. This is also a really loud track, so I'm going to turn the volume down. So yeah, let's see how we get on with that. Oh yeah, and also can we get the editor to work with the other games, so Ruby, Sapphire, and Emerald? But these are really long-term things. I don't know if I'll ever get around to doing these. It really just depends how these sessions go. So I think this track is really distracting, so I'm going to skip it. So yeah, let's jump right back in and kind of go over the code that we wrote last time. So basically we were declaring some of these like structure segments in the stack, and we were originally using fget fget-s, which we realized is not correct. That's not really what we want, so we wanted to use fread instead, and we were doing some error handling there. And then we were reading the checksum value, and we were also reading the save data index as well. So I think where we got up to last time was we can load a file and we can grab some values out of it. So the next thing is really I'd like to just kind of prune out the code that I know I'm definitely not really going to need to use. So I think we have stuff like data fget, yeah, so we probably don't need that stuff as well because we were using fread. So I don't know if it's my volume, but some loud music happening. through my headphones. Yeah, so this is where we got up to. So do we have a goal for today? Well, I would kind of like to effectively enumerate each section and anything else that requires it. So I think what I meant by that is if we look at our article, everything kind of has like a label. Although I don't really know if we need to, like... do stuff here. Although, I mean, I think it would be nice to actually... We're going to need to understand or record the number of bytes that are actually being validated for the checksum. So the section ID, 16-bit unsigned field, and it must have one of the following values. So it actually has an ID number, and then the actual size. Oh, actually, maybe that's in our... Although I say that, that's 2 bytes. So maybe the size is not... I don't know, actually. Maybe, do we have... this number in hex? So F2C. Could we actually search for an F2C in here? There's no data. And it was 16 bits, so... That's not great either. Well, let's actually jump to where we know a section ID actually is, which would be in FF4 inside of our file. So let's go here. Where has it put my cursor? I don't know. FF4? What's going on? Oh, it hasn't loaded my file. Duh. Okay. That was a bit silly. So let's load our file, and then actually, can we search for F2C? All right, so there's nothing there. Let's go to FF4. And this quite simply shows our save data, but then... Oh, no, I guess if this was 16 bits, so... Okay, fine. So actually, what offset are we at here? Does it tell us? FF8. So at FF8, we have our signature, which is the magic number. And then actually at FF6 is our checksum value. So these two are being used for the section ID, and these two are being used for the checksum value, which I guess makes sense. Why is it selected all of those like that? I don't know. Whatever. Yeah, maybe we don't need to actually think about enumerating yet, because what I really kind of want to focus on, truth be told, is calculating the checksum of a section. So we know that we can read the checksum of a section, but what I really want to be able to do is actually calculate it. So I guess what we need to do is actually load an entire section's worth of data. We can just use the first one for the time being, but we want to initialize this structure and straight up read this number. Well, it might not be that number of bytes, actually. It will probably be the same general format, 3968 bytes of data. Now, section ID says the save data being represented as well as how many bytes to validate for the checksum. This is a 16-bit unsigned field and must have one of the following values. So I don't know if this is actually implying that the data size changes with that. So how many sections do we have? 14. And it should be... do we actually have something like this? Yeah. So if we did something like, I want to have base 10, please. 3968. Why did that 3 not work? 3968 plus 2 plus 2 plus 4 plus 4 multiplied by 14. That should give us this number, really, but it doesn't. Okay. So, fine. If we... Can we take our previous number? I guess we can't. 3968 plus 2 plus 2 plus 4 plus 4. And actually, I kind of needed 2 sets of brackets here. Can we do 2? Yes, we can. Okay, so 3968, 2, 2, 4, 4, multiplied by however many use 3968 bytes. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And then we need to not close out that bracket, although I guess we can. And then I guess let's take each of these unique values. So 3884 plus 2 plus 2 plus 4 plus 4. And for 3884, there's just this section. Let me actually move my calculator onto this side of the screen. Yeah, okay. So 3884. Then there's a 3848 2244. And then there is simply a 2000. So 2000 4422. Close out our brackets. This should give us, okay, nowhere close. Dang, okay. Maybe there's some like extra bytes. Or I have a typo, which is very possible. I do wonder if it may just be free space at the end of each save. Because, yeah, I feel like this multiplied by 14 doesn't... Well, we know that it doesn't add up. So... 3968 bytes of data followed by a footer. Does it actually say if there's free space in every section? It might be that I need to like reread this. There's also a cited reference here, which I guess is... Okay, this is just a breakdown of GBA stuff. Okay. Right, let's press on anyway, even though I don't know where this 57,000 number is coming from. Most likely I've made a typo somewhere in my calculations. Or it's just free space. Whatever. So we basically want to make sure that we load this number of bytes into our data structure, but we only have one section. So this kind of narrows the scope quite a bit, which is really good because it shows that we can essentially kind of take the first section and then move to the start of the second one. So it's FFC plus 4, which I think is going to need to be here. So FFC plus 4, okay, is 1000. Oh yeah, I probably should have spotted that. But it's not very often I work with base 16. So at 0x1000, that is the offset that we kind of want to get to, or that's what we want to read into our section, to our first section. So at this point in the program, let's say, what does it do? So we get back a size t. In fact, let's steal this line and put that in there. What we need to do, sec0 checksum. Okay, let's initialize a section and read into that section here, and this needs to be a size of section, number of items 1, save data. So actually, before we do this, I do want to confirm size of a section in hex should hopefully be and it's not going to like this, is it? With suitable LU. Well, I want it to be in hexadecimal. Or, I mean, we could just do the maths. So it's 3968. So 3970, 3972, 3978. If I can do basic arithmetic. I'm doubting myself now because none of my numbers are adding up. 3968. Okay, 3970, 3972. Plus 8. Okay, yeah, so it's 3980. 3980 is what we should be seeing. Or 4096. What? I'm saying FFC plus 4. DEF, yeah. Right. Okay. Oh, maybe there's like padding between these, because actually, if we take 4 bytes up from 8, oh wait, no. Oh yeah, no, that would be, oh yeah, B, and then it starts, okay. 9, 10, A, B, yeah, and then it starts as C. All right, so actually this should be, correct. Well, yeah, I do want to see what our program actually thinks. Also, why am I seeking after I close? Let's not do that. Yeah, let's just do something like this and actually see. What it says the size of a section is. If it will let us. Is F8C. That's in hex. Okay, let's actually do the long and get a real base 10 number, 3980. Okay, so that was what I actually calculated. So I don't know where this discrepancy is happening. Because when I flick between these... See, why is it 4092? That's definitely not what I added up. I think I just don't know numbers. I was never that great at maths, so fine. I'm just going to assume we can safely read this then. So I'll leave this read in. Let's do this validation as well. So if read is -1, Let's say error reading data, and we'll quit. What's happening here? Const, yeah, I guess it's const, sure. Okay, so this should actually write data into our section. So this is going to initialize it with like a load of blanks, and then we will write data in there. So let's see if that actually works to begin with. So let's say checksum value percent %x, and there's actually a way we can print multiple hex characters, or I think it's like hex formatting C, format specifier. Okay, so the hash gives us a 0x in the output string, which is pretty nice. And then the 0 and the x count against your x, your 8 characters listed in the 0-8 part. You need to ask for 10 characters if you want it to be the same. Okay. All right, let's just get rid of that to make it a bit less confusing. And also changing the case of x gives you updated characters. All right, so let's do exclamation mark. And we know that we have 2 bytes in a checksum. So let's say 2x. And that would be, yeah, section checksum. And we need to dereference it. And then, do we need the arrow specifier here? No. Okay. Or maybe we need to reference it. No, I guess it needs to be dereferenced. No. Yeah. Yeah, reference. And it's 0x0. Okay. 0x space 0. So what if we just did 1? Same thing. All right, so we know that our checksum is at ff6. Oh, well, surely it doesn't evaluate to 0, 0. The section ID is ff4. Where are we right now? ff4, which is 0c. So C is actually... Oh, am I like at the actual beginning of my... Okay, yeah, we are. Was I incorrect the whole time then? Because if that's our signature, the checksum is the 2 bytes immediately before. But 0C is 12. So this is actually my PC buffer? Oh, the order of sections gets rotated once. For example, the first ever time the game is saved, the sections are saved in order. Then they will be rotated by 1. So why is 13 first? What the hell? All right, so what was our actual... All right, maybe let's try the next section. So I guess we actually want to jump to probably the next section in here. So let's fseek save data 1000 or 1, or sorry, 0x1 I guess? So we actually want to go to one... Yeah. We actually want to go to this offset so we know that we're in the next section. Because it's FFC plus 4 bytes. We know that we're in the next section. And then we can probably try again. And there's also a null checksum there as well. Let's actually confirm that. So 1 FFC... That's not right. Am I... Oh, sorry, it should be 1 FF6. But even then... The checksum is 2. So that still should have displayed something, even though it would have been wrong. Okay. We can always kind of tell where we are, I guess, because of our magic number. So 25 200108. So we're actually after the signature now in this section. So I jumped... Oh yeah, 1 FFC is actually our save index. But I've tried to read the entire section. I actually don't know if a section is indexable. Like this. I'm guessing it's not because it's having a big old moan. Yeah, okay, alright, it's not. Okay, let's do a bunch of prints and see if anything has been returned. So let's do save index, signature. So I mean the signature I am expecting to show stuff. Although I don't know if this is actually my... I mean, does printf actually... Oh, const char restrict format, and then it's any args? fprintf writes to a stream under the control of a format string, and then you get some kind of return. So if we looked at fprintf, const char restrict format. Okay, sprintf is writing to a string. fprintf writes to a file. Because it's this that's confusing me, right? Because this is a value, is it? And we're taking the address of this value, and we've written a bunch of data to it. So I literally would have thought that actually this doesn't need to be... Well, we don't want the memory address, so we don't need the ampersand. I mean, this won't compile, right? Oh no, it is an address. Okay, all right, fine. So this is definitely what we want. We want to dereference it. But we still just have nothing. We want to read the size of a section. Blarg. Okay. I wonder if we can kind of dump this to a file. Isn't there like fwrite? I need to actually, my bad, I need to actually see how we use fwrite here. So fwrite writes n items objects, each size bytes long, to the stream pointed at by stream. Okay, so actually this needs to be my file restrict stream. Oh, okay, so actually I need to fopen first. And I should probably say this. Let's call this dump. And this is going to be our fopen. And I'll probably take this value here. Put that in there. So that's the file I want to open, and I want to open in write mode. So then using fwrite, we write n items objects to the stream pointer to by stream, obtaining them from the location given to by pointer. So I think this actually just needs to be our section, because that's already a pointer. The size of an entire section once to dump. And it doesn't like this because I guess it needs to be the address. I guess. Yeah. And we probably need to do some error handling here. So if yes, if dump is null, let's just return 1. And we'll do the same here. If fwrite fails, they return the number of objects or the end of file is reached. Okay, this is a size t. If fw is 0, return 1, and that needs to be const, sure. Right, so let's actually try writing this file and see if any of our data was actually loaded. So we now have a binary file here, which I'm going to open in this hex editor. And it's quite possibly completely empty, save for some bytes here. But there's nothing at the very end. And that's not what I was expecting. So the question is, are these bytes actually in our save data? So maybe we want to copy BCD9 all the way through AF. Can we kind of like go to a pattern? BC, C9, D2, A2. So let's search for BC, C9, D2. Okay, yes, it is. Oh, we're actually way past 1000. This is actually 10. Okay, 10740. Does it occur again? Yes, it does. Yes, it does. Yes, it does. All right, so this actually occurs quite a bit in one isolated block of our save file and then doesn't occur again. But for some reason, our section was there. Fclose save data. So we seek, then we read. Maybe let's not seek before we read and actually see if that was perhaps our problem. I feel like it's not though. So I'm going to try again and we'll reload this file. So this should be empty apart from the very end. No. And it thinks the size of a section is, where are we right now? F8B. F8B is F8B is 3979. That's not far off. But it should not be completely empty. Because if we go to... I actually type these incorrect. 2244, yeah. Plug them together. I do wonder... Oh, that's my phone. I do wonder if... This is a 16-bit unsigned field and must have one of the following values. Yeah, I mean, if section... 4 bits... Oh no, yeah, so that is 16 bits because we're allocating it 4... No. Signature 4... Oh wait, yeah, sorry, section ID, yeah. So 8 bits and a byte, and we're assigning 2 bytes. A character is a byte, not a bit, I assume. I hope so. I'm like gaslighting myself now. Okay, yeah, this is definitely wrong. Let's go to our save file and jump to 3980, which should put us... Ooh, there. We're actually... Oh, I think this actually is F8C. Yeah, okay. So in reality, our checksum is still at FF4 like we thought, but I think I've made a false assumption actually that there's... that 3968 is FF4, which it's not. So there is a whole bunch of padding, surely, that's happening, because actually FF4 is 4084. Fuck. Okay. Sorry to swear. I did not realize that. Okay. Okay, sure. So if FF4 is 4084, and if we subtract 3968 from that, we have actually 116 bits of padding. And actually for a section that's 3968 bytes, which I'm pretty sure we were looking at like buffer H, because if that's save number 3, yeah, so if that's being rotated around, actually maybe this should work now? That's probably extremely optimistic. But let's see. Okay, we actually have some values. The save index, so we're not seeking this time. All right, so we need to jump straight to the save index, which is FFC. So 0xFFC, whoops, 0xFFC is 2. Our signature value is 2.5. So maybe can we do 4x? Or is that just going to pad that first byte? Yeah, okay. It is, okay. Oh yeah, I guess because it's each character. So maybe these aren't unsigned cars and we actually want to consider them as numbers. So, for example, section ID, it's saying this is a 16-bit unsigned field. So rather than giving it like a character array, it should be 16-bit unsigned field. I mean, do we have like int types? Is that a thing? Yeah. So a section ID is actually a uint16. And also so is a checksum, I guess. Yeah. 16-bit checksum. So if these are 16, then these must be 32. Guessing it's also unsigned. And then these are no longer effectively arrays. Oh yeah, because they were arrays, so we needed to... Okay, I see. Right. Now that looks better to me. Now the checksum is going to be 0 because there's no data here. And we can prove that by going to FF6, which should... Why are these selected? Select none. Okay. Right, FF6, 0. Lovely. And it's also printed our value correctly with the padding. 80... Oh, wait, hang on. 8012025. This might actually be wrong. Oh no, actually my bad. It's wait, no, it's still wrong. 2520018. What if I do that? I mean, I don't know where 80 is coming from. But of course I am reading from my dumped file. Which is all the way down here. 25200108. I don't know why it's refusing to print that correctly. We are at FFC, and that is our save index. Yes. But then 2520018. Okay, actually maybe that is correct, and it has done the... Oh, well, this... Yeah, little endian. Yeah. Okay, I'm going to assume actually that this is fine. And then maybe this is my first byte of the next section, if that's not right. Because I should have my 4 for my save index, and then we resume the next section. So actually I don't need a size of section +1. If that's the latest dump that I just added. Yeah, that looks better to me. But then what is this at FF4? It is my section ID. So let's see if that has evaluated correctly. Section ID value. Yes, okay. We are getting somewhere. However, I have been recording for a while. I'm on a bit of a time limit today, so I'm going to have to stop there. But I think I understand this a bit better now. It takes me a long time to kind of get to grips with these things. So if you happen to be an experienced programmer and you watch this, and if you've made it this far, which I don't think anyone will, thank you for your patience. And I am still very much learning. Learning by doing, you know, is what it is, man. Thanks again. I will see you in the next one. Bye bye.